All right, today's lessons is going to go over rates. I absolutely love rates because rates are so important, and by using a rate, I'm going to be able to find so many different things. So we're going to be talking about two different types of rates. So just a typical rate is a comparison by division of two quantities that have different units. Units being feet and yards, miles and hours, apples and oranges, boys and girls. Those are different units. Okay, that is what a rate is when you're comparing two things of different units. All right, so there's going to be so we talk about rates, and then we will talk about a unit rate. And I'm going to highlight unit rate because unit rate is very, very important. That's going to be extremely important to our unit, this unit. A unit rate is when the second quantity is 1 unit. That is why it's called a unit rate. Unit means for 1. So a unit rate is when the second quantity is 1 unit. Okay? So an example of that is if I have the cost of milk is $2.50 a gallon. This would be the same as I'm comparing if I were to label. This would be money over gallons. The rate is $2.50 per 1 gallon. That is also called a unit rate because my denominator is 1. One of my quantities is a 1. Okay? That makes it a unit rate. Once I know how much it costs for 1 gallon, it makes everything simple. I can find out how much it's going to cost me for 175 gallons because I know how much 1 unit is, right? So using a unit rate helps to be able to compare. It helps to be able to find how much it is for whatever. So if I go and buy me a Dr. Pepper and I know that I need 15 cans of Dr. Pepper to make it through the day, that's a lot of Dr. Pepper. And I know each can is $1, I know I'm going to be able to have $15 because each can is $1. Same thing goes with cost of milk. Or a Sarah can run 8 minutes a mile. My labels would be minutes and miles. They're different units. So my unit rate would be 8 minutes for 1 mile. It's a pretty fast mile. I couldn't run that. All right, so let's look at my example here. It says, if there are 42 cows in 2 barns, how many cows are in 1 barn? So remember we've talked about doing our fraction bar equals fraction bar. So I already have my labels. So I'm comparing cows and barns. What is it that we know? We know that there is 42 cows in 2 barns. 42 cows in 2 barns. Right? Yes? Mm-hmm. And I want to know how many cows are in 1 barn. So how many cows are in 1 barn? 21. I'm going to divide by 2, and I'm going to get, so my unit rate is 21 cows to 1 barn, or per. Yes?
How did you divide by 2 because it's 2 bars?
That's a good question. So why did I divide by 2? Well, because I know that I have to do something to 2 to get to 1, right? So I'm going to divide by 2. Whatever I do to the bottom, I got to do to the top. I could have also used my cross products because sometimes they're not nice and pretty like that. And so that's where my cross products are going to come into play. I know if I'm finding a unit rate, one of my numbers has to be what? 1, right? Okay. All right, so it says to get the unit rate, divide the numerator and denominator until the denominator is 1. Focus. All right, for example, if I had a rate of 49 to 7 and I want to get to a unit rate, I'm going to divide until my unit rate has a denominator of 1. So for this particular one, what would I do to 7 to get to 1?
7.
I'm going to divide by 7. Whatever I do to the bottom, I'm going to do to the top. And I'm going to get my unit rate is 7 to 1. Yes?
When you divide it, can you only divide it one time? Or can you keep it?
I can keep going all the way until I get to the denominator of 1. Yes? Yes, ma'am.
That 7, could you take the 1 after the bottom?
No. That's a great question. Could I just take, her question was, could I just take the 1 off of the bottom and just say the unit rate is 7? Remember, a rate is comparing two quantities. So I've got to have two numbers. I'm comparing my top to my bottom. So I have to have two numbers. I can't just say I'm going to get rid of the 1 because 7 over 1 is 7, because this is not a fraction. It's a ratio. Yes?
Can your top number be a decimal?
Yes, my top number when we're dealing with when we're dealing with rates, ratios, and unit rates, your numbers can be a decimal. Because remember, these are not fractions, these are ratios. Okay, so I can have a decimal up here in my numerator. Okay, because it might be, what if it's like I have $2.50 per gallon, right? That's money. Because although it looks like a fraction, it's not a fraction. All right. Jennifer drives 2 hours to Grandma's house. If she drives 8 hours at the same rate, how many miles will she drive? All right, so we're going to set up my ratio. I'm going to set my ratio up a little bit different just because I want to do my fraction bar equals fraction bar equals fraction bar. I want to get in the habit of doing this.
Can you pull it up a little bit?
Okay, good.
Sorry, I
Okay.
couldn't see the page.
Oh, that's good. All right, so now I'm going to start with the two things that I'm comparing, hours and miles. My rate that they give me, or what I know, is that it's 8 hours. Oh, sorry, I said that wrong. 2 hours for 120 miles, right? So the rate that they gave me was that she drove 120 miles in 2 hours, correct? That's the rate that they gave me. I want to know if she drives 8 hours at the same rate, how many miles will she drive? Well, I can do one of two things. I can change it into a unit rate and find out how far she drove in 1 hour, then multiply it by 8. Or I can set up my proportion saying, okay, they gave me 8 hours, so where would that 8 go, top or bottom? Bottom. And then I can find out what it is, my x, correct? Using solving proportions. Could I do that?
Yes.
All right. This one's an easy one, so I'm going to multiply by 4, and I'm going to get what? Nope. 2 to get to 8 is going to be a multiply by 4. Or I could have done my cross multiplying and dividing, which will give me the same answer. What is it going to give me? Anybody? Anybody do the math on 120 times? Go ahead. 480 miles, yes? 480 miles in 8 hours. If I had decided to do my unit rate, I could have very well done my unit rate and said, okay, well, if I know it's 120 miles in 2 hours, how much will I drive in 1 hour? And I'm going to get 60 miles per hour, and then find out how much it's going to be for 8 hours, right? 2 different ways I could have solved that. All right, flip it over. A bucket contained 70 gallons of water. Water leaked out of the bucket at a rate of 5 gallons every 2 days. At this rate, how many days did it take for all 70 gallons of water to leak out of the bucket? All right, I love this question because every year there's one just like this on your STAR test. There's one very, 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 very similar to this on your unit test as well. So I'm going to set this up. I'm going to set up, I know I'm going to be doing a proportion. So I'm going to start with my proportions. I'm going to go ahead and identify my important information in here. And I know that it contains 70 gallons of water. And it leaked out of the bucket at a rate of 5 gallons every 2 days. Right? And my question that it's asking me to find is how many days is it going to take for all 70 gallons to leak out? Correct? All right, y'all are just kind of off in La La Land here. All right, so what 2 things am I going to be comparing? Gallons and days, okay? Gallons and days. Those are my labels. Now we're going to go with my rate. What is it that they gave me? What is my rate? Go for it. 5 gallons every 2 days. So I'm going to do 5 gallons every 2 days. With me on that? Remember, everything that's on the top is dealing with gallons. Everything on the bottom is dealing with days. All right. Now I'm going to go with what I need to know. My question says, how many days does it take for all 70 gallons of water to leak out of the bucket? So, where's my X going to go? You have a question?
No.
Oh, okay. Where's my X going to go?
On days.
Under the day, on days, right? Because we do not know that. Correct? Do I know how many gallons needs to be leaked out? Yes. 70. With me on that? I now have set up my proportion. Now I'm going to solve. 70 times 2 is going to give me 140. Divided by 5. How many days?
28.
28 days. Perfect. Perfect. Proportions are pretty easy, right? It's just a matter of figuring out where things are going to go. And as we do practices and practices, you'll get better and better. All right. In Bastrop, Texas, 6 bats ate 72 grams of insects in one night. At this rate, how many grams of insects could 64 bats eat in one night? All right, let's do my important information. I know that 6 bats ate 72 grams of insects. I'm looking at a rate of how many grams 64 bats will eat. And my question says how many grams of insects? All right, set up my proportion. What 2 things am I comparing? Yes, sir?
Bats and grams.
Bats and grams, okay, I can do that. That will work. Bats and grams of insects. All right. I'm going with what is my rate? What did they give me? The information that I know. Landry?
6 bats
6 bats, 72 grams. Now, what is it that I'm looking for? How many grams? Where's my X gonna go, Kennedy?
On the bottom.
On the bottom with grams, yes? And then it tells me for 64 bats, so 64 will go on top. And I will solve that, yes? All right, I can do that. I can do that. Let's see here. Where's my pencil at? $64 times 72, 8, 12, 42, 43, 44. That's what I got. 4,680, or 608, sorry. And then I'm going to divide that by 6. So, did we get an answer? Absolutely. 768 grams. I don't know what it is about proportions, but I love using proportions. I think it's because when I break it down, it's really not a hard process. I think that's what I like about it. All right, a parish in Louisiana with the area of 435 square miles has a population of 9,570 residents. Which rate best represents the relationship between the population of the parish and the area of the parish? All right, let's do my important information. 535 square miles with a population of 9,570. We're trying to find which of these rates best represents. All right, I'm gonna do at least part of my proportion. Square miles and population. What I know is that it's 435 square miles with 9,570 population. All right, so now let's look at my answer choices. There's 435 square miles per resident. The word per, I don't think I know this. The word per means for every one. So 435 square miles per for every one resident. Does that even make sense? Well, we know that that's not right because there's 435 square miles for 9,570, not per square. So we're going to mark that off. So it looks like here that I'm trying to find a unit rate because it says per resident per square mile. So we're going to probably need to go in and finish doing this and finding a unit rate. Looks like I've got per resident and per square mile. So I'm going to do a per person. That's where I'm going to cross multiply and divide. So I'm going to go ahead, well, I can mark off D, can't I? Because it's not 9,570 per square mile because it's, so now I got to find out if it's going to be 22 square miles per resident or 22 residents per square mile. So I want you to do the two. I want you to do this. I want you to find out how much it is going to be per square mile, per population. So do 435. So solve this proportion right here. Solve that proportion right there. just knowing that, before I continue doing my math, just knowing that I'm going to take 435 and divide it by 9,570. Am I going to get a whole number? It's going to be a decimal, right? Are either of those a decimal? No. So I know that we're going to have less than one person per square mile, right? Or sorry, less than 1 square mile per person. So that's going to mark off B, leaving me my only answer is 22 residents or 22 population per square mile. And I know that right now this seems like a lot of information and you're thinking to yourself, oh my gosh, I'm never going to get these rates, ratios, and setting these proportions up and all of that fun stuff. But I promise you, you will. You will. By the time that Thanksgiving comes, this is going to be second nature to you, setting these rates up and these ratios and proportions. So I want you to go ahead and glue this into your journal, and we're going to work on some work.